Welcome back everybody. I am Péter Búzás and this is the 9th chapter of the Crystal Clear Electronics videos. In this chapter, we will talk about microcontrollers divided into 4 shorter videos. Our presenter today is Ambrus Zelei.
So hi everyone from my side as well. You've already seen me in some of the videos. Peter, please introduce yourself to us. How did you meet the Crystal Clear Electronics curriculum?
As a computer scientist, I was introduced to microcontroller programming at university, and later I was involved in the creation of Crystal Clear Electronics too. Now I'm back in the mood to learn more about hardware.
Awesome, thank you. The curriculum of the 9th chapter was written by Gergely Lágler and Viktor Vince and supervised by Szabolcs Veréb. So let's start learning about microcontrollers. You'll be able to watch the curriculum in 4 separate videos. The name microcontroller is quite a mouthful in itself. It's a controller of some kind, so we might suspect that we will be able to control the devices around us with microcontrollers. We can tell you now already that this will be done by programming. The other word is micro. This refers to a small and relatively easy to use device. This is certainly true if we compare the microcontroller with, let's say, a laptop, a tablet, or even a PC.
This sounds great. So the microcontroller is something small but smart. Let's see the details.
To get hands-on experience as quickly as possible, we will build a working device using a microcontroller. There are many types of microcontrollers. The basic principles are similar in all cases. We'll now use the ATmega16A controller to blink an LED. The program code that will be loaded into the microcontroller will be a pre-written code. You will learn about writing program code in later tutorials.
Ambrus, you have an easy job. You have known microcontrollers for a long time, but this is probably the first time viewers will see them. So they may have many questions. What is a microcontroller? What can it be used for? Where can they or similar components be used? How many types are there? What is the difference between them? Why do we use this one?
I hope that we can provide answers to these questions until the end of the videos. You may have come across ICs before, for example in linear power supplies, where a 3-leg IC provided the stable voltage output. You may also have come across the 555 IC, which is an 8-legged component. The microcontroller is a much more complex IC with many more components. This is shown by the fact that it has many more legs than 3 or 8.
So it's a complex tool, but we said at the beginning of the video that it's a lot simpler than a laptop. So how does a microcontroller compare to a PC?
Microcontrollers are much simpler, smaller, and more energy efficient than a PC. Still, it helps to compare them with personal computers or laptops to get a better understanding. After all, PCs are similar to microcontrollers in many ways besides being commonly used. The small parts of the microcontroller have the same tasks as the bigger devices inside the PC. However, they are doing this while they are integrated into a very tiny case. This is where the name integrated circuit comes from. A program, created by us, runs on microcontrollers and PC as well, and this software determines the operation of the device.
It is worth discussing the main parts of a microcontroller. We know that laptops always have a processor, several types of memory, and various peripheral units, for example, keyboard, touchpad.
Very similar components are found in the microcontroller. Let's start with the unit called the processor, which you mentioned. In a PC, the processor completes the basic operations, for example the addition, subtraction, multiplication, and the division. Inside the microcontroller, these tasks are also completed by the central processing unit or the CPU. Also, as you mentioned, there are several types of memory in a PC. A hard disk, or nowadays more commonly an SSD, and RAM, on the other hand, are 2 completely different memory units with completely different purposes. Hard disk drives, or HDDs, and SSDs are non-volatile memories which are used in PCs. Huge amount of data can be stored on them, for example our programs and our files. The data is retained even after turning off the computer. That's why we call them non-volatile memories. Similar units can be found inside the microcontroller. The part which contains the program is called flash memory or program memory. The part which can be used to store other data is called EEPROM memory.
There are more types of non-volatile memories, right?
Yes, external storage options can be connected to the PC if we need more memory. For example, external HDD, USB drive, SD card. Similar options for microcontrollers also exist. As an example, an external EEPROM or the SD card.
We will also talk a bit about the mysterious things called volatile memory. Why do we need a memory that doesn't always remember everything?
This is a bit like what happens in our brains. We can recall parts of our minds years or many years later. But when we speak or count, we store the words or numbers for the time of our activity, but then quickly forget them. The computer works in a similar way. The data stored in the PC's volatile memory won't be retained after the PC is turned off, but this memory is capable for faster operation than the non-volatile, so it gives faster operation to the processor. This is the so-called RAM memory. The same thing can be found in the microcontroller too.
And now, let's gather the most important peripherals.
We can connect different data input and output units, in other words, peripherals to the PC. For example, monitor, keyboard, mouse, printer, camera, scanner, etc. I'm sure that you've met these. Moreover, these devices can be operated easily by connecting a plug or installing a driver software. Different peripherals can be connected to the microcontroller too. However, these are usually more primitive ones. Peripherals can be sorted into two groups in terms of their direction. They can be outputs or inputs. Examples for simple outputs: small display, buzzer, LED strip. Typical inputs: some push buttons or different sensors like temperature sensors, pressure sensor, current sensor, etc. The word sensor can be used as a synonym for the English word sensing.
These devices will complete a desired task only, for example, indicate, measure, or change the given physical information if they are connected properly to our microcontroller, and we have to write a software for the microcontroller which can handle the given periphery.
This is the same as the driver for PCs, for example, the driver of the touchpad under the operating system.
Can we summarize what we've spoken about?
As a summary, we can say that there are several reasons for the existence of microcontrollers. These are small components, though they have much smaller computing capacity than a PC, and their energy consumption is also a lot less, and they don't contain moving components that wear out, so their lifetime is excessively high, and their operation is much more reliable. Of course, reliability requires reliable accessories and software as well.
Apart from the similarities of the PC and the microcontroller, the differences include size, price, reliability, handling, and complexity of the realizable task. You will only learn the fundamentals of microcontrollers in the crystal clear electronics chapters. From there, you can gather years of experience utilizing these tools in the industry. We've reached the end of the 9 chapters first video. In the second video, we will continue with the applications of microcontrollers by introducing the ATmega16A microcontroller. Bye!
Bye!